This is the next part in the series on classes and instantiation patterns. Today we're going to talk about inheritance, aka subclasses. So while classes in general are useful and valuable in programming, they don't really come into their own until we start talking about subclasses. Once we bring subclasses into the fold, the class system makes so much more sense. It's clear why we would use object-oriented programming and how valuable it can be. Okay? So to start off, I want to jump into what we talked about last time, which was what a class is. Right? A class you can think of as a factory that creates something. Right? It creates instances of something. A factory may create cell phones, and those cell phones have useful functionality, which is represented by methods within code. So a cell phone class would create instances of cell phones that maybe have methods on them like .call, .takephoto, and we also looked at the syntax of exactly how that works. But for now, just stick to the big idea. Let's imagine we have a class that creates ice cream, right? Our ice cream class. It's a factory that creates ice cream. Now, what if we wanted to make a kind of modified version of this ice cream, right? What if we want to take a normal vanilla ice cream cone and we want to dip it in chocolate, right? Well, here's my question. We know right now that in this ice cream factory, right? This ice cream factory, there's all the infrastructure, all the machinery to make ice cream and cones and put them together, right? We can imagine there's some giant ice cream mixer that mixes the vanilla and the sugar and the milk and freezes it. We can imagine that there's some sort of waffle press that makes the waffle cone, and then some sort of cone mold that shapes it, and then there's some sort of assembly machine that puts them all together. So if we want to make a chocolate dipped ice cream cone, do we have to make a new factory that has all that same machinery? No. What can we do instead? Well, we can make a new factory, take the work that the other factory has already done, take that vanilla ice cream cone, and then just dip it in chocolate. Right? This is where the word inheritance comes in. If you're not familiar with the word, it often refers to, when a family member passes away, you get some part of their wealth, right? You get some part of maybe land or furniture. You inherit from your parent. You inherit, and in the same way, that's how it is with classes, right? The chocolate ice cream cone factory inherits a vanilla ice cream cone from the parent class. So it doesn't have to reinvent the wheel. It doesn't have to make vanilla ice cream all over again. It doesn't have to make a cone all over again. It inherits, right? Now we can also imagine that there's not just one child class of the vanilla ice cream cone factory. Maybe there's two, right? We have one factory that makes a chocolate cone and one factory that makes a vanilla cone, but they both inherit from this parent class. So what this says is in classes we can have two children for a single parent. In fact, we can have an unlimited number of children for any given parent. Now, I'm going to add one more layer of complexity here. We can also imagine that you have this chocolate ice cream cone, but you want to modify it even further. You want to sell a chocolate ice cream cone with nuts. Okay? So again, does that mean we have to make a factory that makes ice cream and makes waffle cones and puts them together and dips it in chocolate? No, we can just inherit. Right? So check this out. Boom, now we have a factory that produces chocolate and nuts dipped ice cream cones because it inherits the chocolate dipped ice cream cone from this other factory. So this is kind of like the hierarchy of how classes often work. Is we have a parent class which has like the basic functionality, right? Vanilla, it's the most basic concept. Then we have these subclasses that get more specific, chocolate, sprinkles. And then we have subclasses of those that could be even more specific, right? Covered with nuts, okay? So you may wonder, how does this apply to software engineering? Well, I want to give you one real-world example where classes were almost certainly used. This is a game called Plants vs. Zombies. You may have heard of it. In this game, you have a kind of board, and zombies come from the right side of the screen. I guess. Wait, they come this way. That's really hard to do. They come from the right side of the screen, and you have to plant these plants to defend the zombies to protect your house, right? Now, what does this have to do with subclassing? Well, first of all, there's a lot of different types of plants, right? But they all have basic functionality, like they can be placed on the board, they can be killed, right? They can be planted. So imagine that in the code here, there's a class called plant. Now plant, it's not any specific plant, it's just the functionality that all the plants share. It can be placed, it can be killed, and then from there you have a subclass called sunflower plant. And this sunflower plant has functionality like produces energy and it looks a certain way. And then as another class, you have the pea shooter plant, which can shoot peas. But they all inherit the basic plant functionality from some higher level class, some parent class. The same way, we can imagine that with zombies here. Let me scoot to where there's a bunch of normal zombies. There's different types of zombies. We see there's a normal zombie, there's a cone zombie. So we can imagine that there's some parent class called, enemy. And enemy walks, it can do damage, it can die, but it's not specific. And then from that enemy class, we inherit the cone zombie, we inherit the walking zombie, we inherit whatever other types of zombies there are, the ice zombie, the sword zombie, I don't know the different types, right? But the benefit to this is we don't have to rewrite the basic zombie functionality every time. Instead of having to rewrite walk, move, die, every time we just make the class once, and then we make subclasses that inherit those properties. And that is the fundamental concept of subclassing. It is incredibly common in software engineering, right? This idea of subclassing and object-oriented programming. One more quick example. You remember Blinky Dancer. Maybe you've done it yet, maybe you're about to. But in Blinky Dancer, you create a bunch of dancers on your screen. And maybe there's a generic dancer class that can move and can dance, and then that subclasses to the dancer who does, the floss, or the dancer who spins, or the dancer who's red and circles around the screen. But they all inherit from that basic functionality of the top level basic dancer. Okay, so that's subclassing. Next, let's jump into code and see how this looks.